Good morning, everyone. I think a few people are still joining, so I'll give it just a couple of seconds here. Good morning, everyone. I thank you for joining 6 Tech Tuesday today. I hope everyone is doing well in these unique times. On the right, you should see a chat feature. Feel free to chat to each other or to me. And below that, there should be a question section. Please type any questions in that section, and they will be answered at the end of the presentation. Also, the last slide will have my contact information, and you're welcome to call me or email me for further discussion. We appreciate your time today. Today's subject is ammonia slip measurement with 6 GM700 in situ gas analyzer. Still have people joining. Here's the agenda for the 30-minute program. Probably won't take the full 30 minutes. There'll be time for some questions at the end. We'll first look at who is sick and some of our analyzer products, where they are used around SCRs and emissions monitoring. We'll take a detailed look at the analyzer itself and the technology, and finally concluding with questions and hopefully some answers. If I can't answer them today, I will get back to you. So who is SICK? SICK is a global technology and sensor company. Our main businesses include presence detection. This can be people, objects, factory automation type lines. We also do industrial safety. This is machine guarding, light curtains, analyzers, which is the topic of the day today. We do flow measurement, custody transfer of natural gas, flare flow, stack flow, and SIMS applications, industrial integration space, and analytical systems integration as well. We do motion control sensors. This is around robotics, identification and measuring. This is baggage systems in airports, logistics companies like Amazon and FedEx. So SICK is in a lot of businesses and in most industries. For today, we're discussing analyzers. This slide shows the breadth of the analytical product line. SICK offers extractive analyzers. This is the MCS100E being shown. This is a hot wet extractive SIM system. We probably have in excess of 3,000 of these installed worldwide. Next to this, you see the MCS300P. It's a raw gas analyzer, still a hot wet analyzer mainly for process type applications. And then we have the standard continuous gas analyzers, cold draw extractive SIM systems, also used in process applications where there's a clean, dry gas as opposed to the wet gases in these. And then on the right, we have in situ analyzers. The GM32 is for NOx and SO2 mainly. The GM35 is for CO, CO2, and water, infrared components. The 32 is UV based. The Zircor is for oxygen. It's zirconium oxide based. The topic today is the GM700 TDLS, tunable diode laser spectroscopy. It's an in situ gas analyzer for measuring ammonia, HCl, and hydrogen fluoride. We also have dust products for particulate monitoring and opacity. And we have a flow product for stacks and emissions monitoring as well using ultrasonic flow. So you can see here, SICK does a lot of applications around emissions monitoring, and SCRs are included in that. So why do we measure ammonia slip? Well, the EPA regulations have greatly reduced allowable NOx emissions over the last decades and years. Technologies such as low NOx burners, SCRs, selective catalytic reduction, and SNCRs, selective non-catalytic reduction, are used to reduce NOx in combustion applications to permitted levels. SCRs require ammonia injection and heat to reduce NOx to N2 and water, nitrogen water, to a chemical reaction. In this picture, you'll see an SCR. The catalyst bed is in this area. Flue gas comes in, ammonia is injected, and on the outlet, the NOx is reduced to nitrogen and water. Well, most of it is. Reason for the measurement: ammonia slip is the excess or unreacted ammonia that exits the SCR. This is an undesirable pollutant. It's regulated by some states through permitting. I think by most states. In power plants, it affects the fly ash, which is sold as gypsum. Um, uh, Based on your permit, you may have to do quarterly checks or stack testing and or measuring. It depends on the state that you're in. Ammonia slip affects the efficiency of the catalyst and the life of the catalyst. It can cause, too much of it can cause ammonia salts buildup, which can cause corrosion. And ammonia is expensive. So if you're putting too much in, it costs money. So there's a lot of good reasons to measure in addition to EPA regulations. So the GM700 TDLS is a single-sided probe. It's an in situ measurement for fast response. It measures in low ppm ranges. It's well proven in ammonia slip applications. We have a lot of these installed. There's different options for different temperature ranges, which we'll take a look at later. It is available for hazardous areas for Class 1 Division 2 and ATEX. It has a built-in check cycle for daily checks. It's suitable for stream compositions with a lot of water, and it has a 6-month maintenance interval, so it's low maintenance as well. It's a pretty good choice for ammonia slip. So in an SCR, we have a catalyst bed. It is a reactor, basically. The flue gas comes in, and when the flue gas comes in, we have an opportunity here to measure NO. So this is a different measurement from ammonia slip, and we use the GM32 in situ analyzer to measure NO here, and this gives us a feed-forward signal to the ammonia control system. And on the outlet of the SCR, we have another opportunity here to measure NO to calculate the efficiency of the SCR, and this is where we would measure ammonia slip as well. So in addition to the GM700 for our ammonia slip, we also offer a feed-forward signal using the GM32 UV analyzer to measure NOx. It's also an in situ measurement for fast response. It's very high dust tolerant. Single-sided mounting is available. It's offered for low ppm ranges. It can be dual range, and it's well proven in this application as well. And it's also available for Class 1 Division 2, and has the daily span checks for check cycle. So you can do a check cycle, a daily check without having to use cow gases. And it too has a 6-month maintenance interval. Now, there's 2 types of reactors. There's an SNCR, which is selective non-catalytic reduction. In these, we direct ammonia, we inject ammonia into the flue gas, but there's no catalyst bed. So all we have to do here is measure the ammonia slip. On SCR, we do have the catalyst bed, so we inject ammonia, and we can measure the NOx going in and provide that feed-forward signal to the control scheme. And then on the outlet, we would measure ammonia slip, and potentially you could measure NO again there, or that could be measured on your SIM system as well. So continuing with where does it fit? Combustion processes and emissions controls. So any place around a stack, an SCR, we do FGD controls as well. With the GM32, it measures SO2. So we can provide a feed-forward control to lime injection. SCR, SNCR controls, combustion controls, flow measurement on the stack, opacity, particulate measurement, hot wet extractive SIMs, cold dry extractive SIMs, and we can do both in situ and extractive measurements. So in the emissions world, this is kind of who we are. So now to take a look at the GM700 technology. It's a tunable diode laser spectrometer. It's a laser analyzer for highly reactive components such as ammonia, HCl, and HF. Pick any one. We can't do all 3 at the same time. However, we can measure ammonia and water at the same time. It's very, very reliable. It's very low maintenance. It's drift-free, has no moving parts, and it can be calibrated without a test gas. There's no sample system, so there's no sample system complications. It's 100% in situ, and the ammonia version is available for hazardous areas with a Class 1 Division 2 rating or ATEX. features high selectivity due to the high spectral resolution. There's no cross sensitivity. It's in situ measurements directly in the process. So it's an unaltered sample with a fast response. We offer both a cross-duct version and a probe version, so it's very flexible. It is suitability tested and approved with a 6-month maintenance interval. And it's very reliable. It's drift-free, can be calibration-free. We know this isn't the case with EPA regs. But no sampling and conditioning of gas, no moving parts. So it's very low maintenance. It's very, very reliable. More about the technology. If you can imagine this as being the infrared spectra, one gas has absorption peaks in these areas. You add a second gas or a background gas to that, and you have other absorption peaks, and some of them are on top of each other. In the infrared range, when we use an infrared analyzer, we're measuring this entire or a good part of the spectra. Even though we use wavelength filters, it's still a pretty wide band. With TDL, with lasers, we're able to narrow that band down to a much smaller area and only look at the peak that we're interested in. So that's what we mean by high spectral resolution. We're only looking at one peak in the spectrum. I'm going to pause here and turn on a video. We'll take a look at the inside of the unit. This video is a little bit kind of slow, but I'll try to narrate. Here's the Pro version for high dust applications. We also offer a cross-duct version or cross-stack version. So inside of the analyzer, we have the laser. It shoots the laser beam and hits a beam splitter. It goes out to the reflector and bounces back and hits the detector. Now the beam splitter branches off to a monitor channel and a reference channel. So in one measurement, we're really doing 3 measurements. We're measuring the actual signal, a reference, and the monitor channel gives us a baseline. So we're able to take those 3 measurements and do a normalization of the curve. We're comparing the reference and the measuring. That gets compared to the baseline, and we're able to normalize this into a flat curve. This shows the absorption peak. See that here. And then we use a curve fit. So we take one curve, we look, it doesn't fit. We take another one, we actually see that's ammonia. And then we keep trying curves until we see one that fits, and that gives us a value. In this case, it's 1.77 pp. So there's no moving parts. Therefore, it's wear-free. It's a direct spectroscopy. And that gas field reference cell is for long-term stability and provides line locking. Line locking is something that happens with laser type analyzers. They can drift off of the spectral line that they're supposed to measure. So with each scan, we check that reference to make sure that we're looking at the right line. I lost my cursor. That automatic self-check function, we use that internal reference cell, and that gives us a span check, and we use the internal monitor channel to give us a 0 check, and we can do a self-check. During this self-check, it keeps the analog output at the measured value. That is configurable. You can't change that. And the self-check is possible without cal gases. The self-check can also be manually initialized. You may want to do this if you're doing a check of the analyzer. We can also, with the GPP probe, which we'll take a look at next, and the only with the GPP probe, we can actually do a zero and span check in place with a cow gas. And then we have the GMK10 external cell. We can remove the analyzer head from the probe and attach an external cell and do a cow check with cow gases. This is something you might do on an annual basis. It depends on your permit, and you can equate that to doing a CGA, a cylinder gas audit on a SIMS analyzer. It's kind of the same thing. So we have two different types of probes available. The first one is the GMP, which is a gas measuring probe. It has an open path. That stinger you see is actually an RTD to measure temperature. So the open path probe is typically what we use in ammonia because ammonia is very sticky. We also have the GPP. We can use this open path probe if your stack temperature stays above 300 C. The GPP probe is a gas diffusion probe. I'm sorry, I said that backwards. The GPP probe is a gas diffusion probe. We can use this probe if your gas stays above 300 C. Below 300 C, we use the GMP. So this is a centered ceramic filter that goes across the measuring path. And then thirdly, we have the cross duct unit. So we just have the analyzer head on one side of the duct or stack and the reflector unit on the other side. For the cross duct unit, it's good from 0.5 meter to 6 meter duct diameters. However, if it's a dusty application, which a lot of these are, you cannot use the cross duct. We need to stick with one of the probe versions. And the probe versions eliminate things like alignment issues and stuff as well. We also offer a purge air unit. For the GMP and the cross duct unit, we have to have purge air across the optics to keep the particulate matter out of the analyzer itself and the optics clean. We offer a weather protection hood and a defect for high dust applications using the GPP probe. We have a abrasion protection plate that we can mount in front of the unit. Here's the typical configurations. This is a cross duct unit with a blower. If you have any amount of high pressure, we'll need 2 blowers in this application. And here's the GMP probe, which is typical for ammonia using the GMP. We will have a blower as well, and that blower can be certified for Class 1 Division 2 also. In both cases, the analyzer head is connected to a remote set of electronics. It's called an evaluation unit, and this is where your I/O is handled, and it has a local display on it, and you can do configuration with a laptop computer or do a communications to your DCS if you're not using analogs. So this concludes the presentation portion. SICK Incorporated is a global company. We service multiple industries with a lot of different sensor type products. We have a lot of products that are well suited for SCR control, from NOx measurement on the inlet and outlet to SIMS and ammonia slip on the outlet of an SCR or SNCR. SICK GM700 offers fast response. It's a very unique design with the Pro version. It's very well proven in the application, and it's very low maintenance. So we will open this up now to questions, and I may end up giving you a little bit of your time back today. Okay, I have a question that came in. How much money can be saved by not using cow gases for daily checks on average? You know, that's a good question. I looked at an application just the other day that one of my colleagues did some years ago, where these were on SIMS, and they switched to in situ SIMS, and they estimated the savings at $40,000 a year, which is a bit high, but there's obviously will be a savings if you're not using a daily calibration gas, because that just goes away. You may still need gases on an annual basis or maybe 6-month basis, depending on your permit. You can see my name and phone number and my email address here. You're welcome to contact me at any time and answer other questions. Give it just a minute for any other questions that might come in. Okay. I'm not seeing any other questions, so feel free to reach out to me and contact me if you do have questions. Thank you again for attending our Tech Tuesday today, and continue to look for other opportunities. We will be doing these every Tuesday on a different topic each time. And again, feel free to reach out to me if you have any questions. Thank you all. Have a nice day. Have a safe day, and hope everyone fares well during this unusual times. Goodbye.